Good evening, students. So let us move on to the atomic models of chapter 2, class 11th. So the next model is the Rutherford atomic nuclear model, in which he proposed the discovery of the nucleus. Okay, before the Rutherford, there was a model proposed by J J Thomson, in which he said that a whole sphere is made of positively charged particles, and in which that the small minute particles are the electrons. It was also known as the plum pudding model or the watermelon model. It was just similar to the watermelon. As we cut the watermelon, what we observe? We observe that the whole of the outer layer is made up of somewhat positive charged, and in between the seeds of the watermelon, those are the electrons. So he proposed that model, but that model could not work, and then the next model came, which was the Rutherford's nuclear atomic model, and in which he proposed the discovery of the nucleus. So what all setup was done, we will see over here. What was his observations and what all he concluded. All these things we will learn today. So let us see the setup which was made by the Rutherford. Rutherford had taken a source of alpha particles, then a lead plate or a lead chamber. It was hole covered. The source of alpha particle was covered with this lead plate. Then he took a gold foil, as the name is the gold foil experiment or it is also popularly known as Rutherford's atomic nuclear model. Okay, it was done around in the year 1911. So then he also took a photographic plate, which can be of any material, which can be example ZNS, zinc sulfide, which can be of zinc sulfide. So he took source of alpha particles. Now how he came to know that these are alpha particles or the positively charged particles? He took a helium atoms and he removed the electrons from them, as the helium atoms has got 2 electrons. So he removed the electrons and the atoms of form became the alpha particles. So he took those alpha particles over here, he took a source of alpha particles, then he had placed those particles in the lead chamber or the lead plate. Why he had done that? He has placed on the lead plate and he focused on the lead plate, or he had enclosed it in a lead plate, because so that the alpha particles are not distracted or are not focused on any other point. He had to only focus on a gold foil, and he had taken a gold foil on which he made them to focus. So what he observed, he made to focus, and at the back of the gold foil he placed a photographic plate. A photographic plate can be any of the plate, but he had taken zinc sulfide. It is any of the plate which could show the alpha particles being scattered or not scattered, what all can happen with this plate. So zinc sulfide is the best photographic plate on which the alpha particles can be scattered. So what all he observed? He observed 3 things. 3 observations were seen by Rutherford. The first observation was that some of the particles did not deflected and they passed away straight away, and some of the particles got deflected and they made a deflection angle like this over here, and they deflected in different angles. Like here, this was deflected over here, this is deflected over here, this particle is deflected over here. So they were deflected by different angles. This is the beam of alpha particles shown over here. So they were deflected by different angles. And the third observation was that some of the alpha particles got scattered back. They've just scattered back. So according to those 3 observations, he made some conclusions. The first conclusion which he made was most of the space in the atom is empty. Means if my alpha particles is passing straight without any deflection, so it shows that most of the atom in space is empty spaces are there, and the alpha particles are straight away passing from them, okay. Then the second observation he made, some of the particles got deflected, alpha particles got deflected by some or the other angle, So from that he made the conclusion that the few positive charged alpha particles were deflected due to the enormous repulsive force, showing positive charge of the atom is not spread throughout as Thomson suggested. So it concluded to Rutherford that why this repulsive force had taken place and why my alpha particles got deflected by the some angle. So it was because they were striked or hit on the positive charge of the nucleus of the atom. They were hitten or they were striked on the positive charge of the atom, and we know that the like charges repel. So as the repulsive force was very much greater, so the alpha particles got deflected by different angles. So it depends upon how much repulsive force is there. Whatever the repulsive force they got, they reflected with that much angle only. So it concluded that some part of the atom is made up of positively charged particles, not that the whole of the atom is the positively charged, as the Thomson just suggested. Actually, the Thomson suggested in such a manner that it was J J Thomson who suggested in such a manner that whole of the atom is positively charged, and the electrons are like the seeds of the watermelon. It was suggested by the J J Thomson, but it was proved wrong by the scientist Rutherford, and he said if the alpha particles are being scattered, if they are deflected by some angle, that means it is getting some repulsive force, and the repulsive force is not throughout the atom but somewhere in the atom there is a repulsive force. He suggested that. He made the conclusion in this way. Then he made the third conclusion. In the third conclusion was that as the alpha particles hit the gold foil, they just deflected backwards and they scattered backwards. Why this happened? This should happen. He made a conclusion. This should happen if it contains a nucleus of dense heavy mass but having the radius very much smaller, and volume occupied by nucleus must be very much negligible. The volume occupied is very much negligible, but it should be very much dense. It must be so much dense that if something strike towards it, it gets backwards, it gets hit backwards. So he made a conclusion that there must be a nucleus in the atom, and that nucleus is having, and when he made the calculations, he got the conclusion that nucleus is having the radius of 10 power minus 15 meter, and although the radius of the atom came out to be 10 power minus 10 meter, so the radius is very, very much smaller than that of the atom, but the volume occupied by the nucleus is very, very much negligible, but it is very much dense. It is very much dense. If we hit something on the dense platform, suppose we can take an example of a ball. If we hit a ball on a dense platform, the ball returns back to us. So it was similar, that the case was similar in this manner. As soon as the alpha particles got hit to the nucleus, they were hit to the dense platform, and they were hit backwards to the same source. Like this. They were hit backwards to the same source. You can say like this, they were hit backwards to the same source as soon as they hit it to the gold foil screen. Okay. Gold foil. Then the next conclusion he made, the positive charge and mass of the atom are densely concentrated in the small region called nucleus, and he made the conclusion that atom is composed of the small nucleus, and the small nucleus is nothing but the positive charge and mass of the atom are densely concentrated in a small part, and that small part is nothing but the nucleus. So he made the discovery of the nucleus. At that time, it was not known that nucleus is again made up of proton and neutrons. At that time, it was not known, and Rutherford was only able to discover that the small part in the atom is nucleus, and that small part it is densely concentrated. It is a densely concentrated region. It is in the densely concentrated region, and also he then further concluded that the electrons revolve around that positively charged part, which is we call the nucleus, and they revolve around it in the orbits. They revolve around it in the orbits. So we already know that there are K, L, M and shells, and the orbits are there around which the electrons revolve. So these conclusions were given by the Rutherford. These conclusions were given by the Rutherford. So this was all about the gold foil experiment, in which he was able to give the discovery of the nucleus. Basically, what is the nucleus? So people came to know what the atom is, what the atom is having. Atom is having the positively charged. Obviously, it is having the positively charges, not as a whole spreaded, but in few regions, not as a whole region, but in a few regions. And also it contains a part which is known as the nucleus. So he was able to give the discovery of the nucleus. So this was all about the Rutherford experiment. Okay, so please share my videos, please subscribe my channel. Okay, thank you.